Dear participants of the conference, I'd like to present you our report on the topic System Modeling for Water Use and Wastewater Management in the Ingulets River Basin. River Basin as a complex system belongs to the most important objects in system management, and it is a system with established ecological, social and economic ties. The peculiarity of such systems is that they describe objects that have fundamentally new properties such as hierarchy, structural organization, adaptability, controllability in conditions of uncertainty and risk, multi-criteria in assessing functioning. This means that the management of this system can't be carried out by separate analytical or statistical methods. It must be considered as an integral socio-ecological economic system, the coordination of managerial decisions of which is achieved by applying the methodology of system management. System modeling as a toolkit allows you to apply a structurally functional approach for integrated river basin management. However, each basin has its own specifics and subsystems which should be reflected in the integrated management model. The structural and functional diagram of the Ingulets River Basin system model was developed. The structural subsystems were identified such as 1. The water supply subsystem by the Dnipro-Ingulets Canal, water supply along the river channel and the filling of the Karatunyivsky Reservoir. 2. A subsystem for flushing the Ingulets River from the Karatunyivsky Reservoir with the displacement of the saline prism into the Dnipro River. 3. A subsystem of environmental safety when discharging influence by polluting enterprises into the Ingulets River. And 4. A subsystem of water supply for irrigation in the Ingulets irrigation system, prevention of soil salinization. In the water supply subsystem of the Dnipro-Ingulets Canal, the water level is controlled and the Karatunyivsky Reservoir is filled according to the criterion of supporting water levels. Flushing is necessary to displace the salt water prism into the Dnipro River, which is formed as a result of pollution by enterprises between the dam of the reservoir and the Andriivka village. The result of flushing should be the achievement of a good ecological river status and the supply of water of satisfactory quality to the Ingulets irrigation system. In the combined control system, a positional component is set, an open line for planning the sequence of impulses in time with their discharges from the reservoir and is adjusted in the control process. Decision-making about the next impulse is made using a function that evaluates control actions based on input and output values, that is, feedback is used. There we can see a Q of x t n plus 1 is the impulse at the next n plus 1 time moment. F is a function that determines the decision-making algorithm. R is a reservoir. Q1, Q2, etc. are uncontrolled water flows from diffuse endpoint sources. VIP is water intake point for irrigation system or for industrial needs. SPMW is the state of the prism of mineralized waters. DMU is a decision-making unit. A is positional component of the combined control system. MDIC is management of the Dnipro-Ingulets Canal. The choice of structure options in the management system involves the optimization of economic goals on a variety of simulation scenarios omega. Formula 1, where F1, Fn are economic criteria defined as the total cost over the t interval to evaluate the quantity and quality of water resources. X of t and U of t are the system and control states at time moment t respectively. In addition, as the control interval t on a variety of control scenarios omega, environmental goals are taken into account that are set as limitations or as criteria for achieving the required water quality in the river basin system. Nowadays, there are no technologies for treating highly mineralized mine waters that would be economically available and provide the necessary reduction in the mineralization. That is why before discharge, main water accumulates in a storage pond. Before the mine water is discharged, its normalized dilution with purer water is carried out to reduce mineralization. The discharge of mine water into the Ingulets river is carried out in the mid-growing season using water from Karachunivsky reservoir. During the growing season, the riverbed is washed and rehabilitated. This ensures the supply of water to the Ingulets irrigation system and prevents soil's salinization. Accumulation of mine water in a storage pond requires economic costs, which are carried out exclusively at the expense of mining enterprises due to the fact that wastewater flows through one pipeline to the storage pond from all enterprises together. The share participation of mining enterprises is determined by the balance equation for water volumes. We proposed a mathematical balance model in which the determination of the share of participation of enterprises is carried out jointly in terms of volumes and indicators of chlorides. Formula 2, in which the value K of lambda formula 3 expresses the share participation of the I mining enterprise. In table 1, we can see initial data and results of calculations of the share participation of mining enterprises in Kyiv in the accumulation of excess water in the storage ponds of the Svistyanov Gully in terms of volumes and mineralization in 2019 by different methods. Within the second subsystem difference balance equations for the dynamics of the propagation of water and minerals in a river flow are proposed. The balance of water masses in a sequence of cells on a river section under conditions of point and diffuse sources is determined by a system of difference equations for the conservation of masses and continuity of the flow. Formula 4. The point source is given by the piecewise function, formula 5. The balance equations for the dynamics of the transfer of contaminants after mixing have the form formula 6, where UIN plus 1 is a concentration in the east cell at the n plus 1 time moment. Concentration UI1 and water resources in the first cell W1 n plus 1 calculated by the formula 7 are set on the left border. We have boundary conditions. To determine management decisions when the concentration goes out of the permissible range, simulation modeling is carried out based on the proposed models 4 and 6 with a discrete source of pollution. For this purpose, a software application of the models has been developed. Based on the simulation, the concentration UN in the N section, the section of complete mixing at the nth moment of time, is determined. On figure 3, we can see the dependence graph of the concentration at different distances from the pollution source at different time moment n. As you know, to implement a system model of water resources management, the Ingulets river basin was selected. The water level in the Kyiv reservoir is maintained by replenishing water from the Dnipro-Ingulets canal and the natural river flow. A scenario analysis of the options for integrated river flushing control was carried out according to a system of criteria. The optimal scenario 3 was selected according to the Pareto principle, which provides for the operational management of the river flushing based on 3 pulses. Feedback is carried out on the content of toxic ions of anion chlorine to prevent the negative process of the soil salinization under irrigation conditions. According to the scenario, the ecological component of leaching is improved without artificial flooding and entering the backwater. Compared to the non-feedback flushing method existing in 2019 in the combined control system, water quality remains within the MPC. According to the economic criteria, the proposed combined management system uses only 160 million cubic meters water for flushing the river, and the existing flushing system is much larger, 190 million cubic meters. Therefore, it is recommended to increase the washing period from April 1st to September 15th. A comparative analysis of 2 flushing methods showed the great effectiveness of the method with feedback on environmental criteria and the magnitude of the water intakes for flushing and irrigation. So the proposed system model allows for the integrated management of water use and drainage of saline waters in the river basin. The balance sheet method is a tool for determining the equity participation of enterprises jointly based on environmental and economic criteria. This stimulates enterprises to reduce the volume of wastewater discharged into the storage pond and, according to environmental criteria, to the introduction of technologies that reduce the pollution of these waters. Water dilution control system in the Ingulets River allows optimizing water consumption by economic criteria to maintain water quality within acceptable limits based on modeling and control of water quality in a fully mixed section. The analysis of the proposed control system carried out on the basis of modeling showed the possibility of a significant savings in water resources in comparison with the existing flushing method. At the same time, the water quality is maintained within acceptable limits, while with the existing flushing method already in August and September, the chloride index exceeds the maximum permissible concentration. Thank you for your attention.